Hello, my name is Robert Harrison, and today we're going to be looking at the modifications that need to be made to the T962 reflow oven, a nice cheap Chinese reflow oven, to attach this controller upgrade card, which adds what I consider to be essential functionality to the original controller. This controller upgrade card is quite small and it attaches to the ISP interface on the main controller card. It adds 4 thermocouple connections, and it allows you to control the onboard fan, and also supports the addition of a thermal fan should you wish to install one inside the oven. My personal belief is that's actually not necessary. I did have a play with it, but I think if you actually just install this card, install the thermocouples, modify the profile to match the boards that you're actually trying to reflow, and you're off and away at that point. And I would save yourself a lot of time and effort by not trying to install an internal thermal fan to circulate the air inside the oven. However, the modification to remove or to turn off, or quite simply to control the small air circulation fan in the top of the oven, which is pretty annoying. As soon as you turn the oven on, you'll hear it. It's fine at first, but after about half an hour, it gets really, really annoying. That modification is also, as far as I'm concerned, essential. On board is also a UART chip, which allows you to actually reprogram the onboard firmware quite easily. So by connecting this card, you should be able to reprogram the firmware, upload new profiles, monitor what's actually going on during the reflow process, have accurate and working thermocouples inside the oven, and control the onboard fan. So I think we shall have a quick look at before we can add this board to the ISP connection, we need to bend over the capacitor just underneath the ISP connection. Let me just get my tweezers and hopefully I can show you that. Right, here we go. This is the I think it's 0.7 microfarads, and it's 50 volt. What I've done, I've just bent it over. It seemed to have a little bit of play within the lead length, and it didn't seem to make any difference just pushing it over to one side. If you feel uncomfortable doing this, you can either buy a replacement, or if you've got one handy, desolder this one and solder in a new one, leaving a bit of length on the leads and then bend it over. However, I've had no adverse effects in just bending this over like I've done here. It's electrolytic capacitor. They're pretty easy to come by. Shouldn't cost more than pence from any electrical shop. Or indeed, just have a look around. You may well have one kicking around if you've got one of those big bag of capacitors. Right. These are the wires I'm going to use to make the modifications to the existing controller board. We'll call this one the motherboard, for want of a better word. That's sort of a PC word, I know. And this will be the upgrade controller card. So these wires are quite nice. They've got these nice little metal connectors on the end, and they're very convenient for inserting into the Phoenix connectors, the green Phoenix connectors, the screw terminals on my upgrade card. You can also replace these with what we call bootlace ferrules. They're my more favourite solution. I think they just look a bit neater, and they're also a bit closer together. However, if this is all you've got, then use them. This is an example of the ribbon cable I'm talking about. You can get these very cheaply off eBay. I think maybe $1 or $2 for a 20 cable, and they're quite useful. You can use bits of them, just tear off the number of cables you want and make the modifications. It's multi-stranded wire, so it's very flexible. You don't want to use single-stranded wire, although to be fair, we're not moving this around very much, so it probably wouldn't matter too much. What else am I going to say about that? Not much more, I don't think. These bootlace ferrules are quite schematic. Right, so I've trimmed back the wires here. As you can see, stripped the wires, taken off the connectors, and we'll look at the points where we need to connect these wires to on the motherboard. Right, this first one, so we're talking about the sort of the top the connectors here. The C20 pad there, the top one, that's where you're going to connect for 3.3 volts. The one next to it there, the R2 one, is actually going to be the one wire interface, and finally that ADO test point is also connected to another pin on the microcontroller, and that will be used to control the micro fan in the corner of the oven. Right, so I'm going to add a little bit of solder to the end of these wires just to make the connection a bit easier. I think actually first of all we'll add some solder to the connection points. Let me just get my solder. Right, bring it in. I'll try and keep out of the way of the camera as best I can and try not to knock it around too much. It's obviously a bit tricky trying to do all this in fairly close proximity. So this is on the one wire interface, just putting a little bit of blob of solder on there. It's worth re-tinning it and putting a fresh blob of solder on there. There's still be a bit of flux in it and just makes the connection so much easier. Put a blob of solder on there. That's going to be the 3.3 volt supply. Looking good. And finally, this is the ADO connection, and this will be the point that's controlling the fan, or will be the actual pin on the chip that will control the fan. Yeah. Too bad, just if too much flux on there. Whoops. I have to apologise about the audio on here. I did record the audio at the time. However, unfortunately, my radio microphone was actually switched off, so I've had to go back and overdo the audio on here. That's why it seems slightly out of sync. Right, here we tin up the. This is going to be. I'm going to use a red wire for the voltage supply. It seems to be pretty standard practice. This is going to go to the 3.3 volts. This is quite tricky. Trying to do this in front of the camera. Here we go. Come on. Ooh, there we go. Got it. A little bit more. Oh, that'll be enough. Right. Actually, before I make that connection, I'm just going to bend the wire over a little bit at the end. There we go. It just makes it easier for, well, particularly demonstrating on the video here, like so. Make sure we don't want to get it onto the ground pad on the other side. I think it's a ground pad, almost certainly. We just want a nice, simple connection. There we go. That's looking good. Little tug. Yep, nothing wrong with that. So the next one will be the one wire interface, which is going to go into R2 there. We'll just grab that cable, bring it across, try and tin it a little bit. Just pull out the wires, make it nice and flush together. As you can see how badly I shake now trying to do this. My hands are pretty well extended trying to do this as well. There we go, just use the top of this cap as a little table. There we go. And we'll just bend the wire over at the end again. Oh. There we go. Once again, be careful not to have it touching on the pad opposite. I think these are, looks like 0804 connections. There we go. Perhaps just a little bit closer to that pad. Let's just back this back off again. And here we go. Yep, that's looking good. 1, 2. You can always test these with a multimeter if you're worried about the whether it's actually clear against the other pad. You could just do a little continuity test. But I'm quite happy with that. So the final connection we need to make. I say it's the final connection. We also need to worry about the thermocouples in a bit. But this is the final modification or final bodge to the original controller board, or as we're calling it, the motherboard here. That's all good old PC speak. So let's get this cable. I've tinned it already. It was easier just to do it around the corner there, and just very quickly. There we go. Lovely. Right, they're the 3 connections that we need to make. And the next thing we probably ought to have a look at is the thermocouples. We need to release it. You can see all that sort of white stuff that looks like toothpaste everywhere. It's actually silicon, high temperature silicon sealants, and they use that to try and prevent any thermal releasing of the screw terminals or of the joints. You can pick it out here, which is what I'm doing here with my tweezers. I'm going to go picking the bits out. It can be quite slow. You don't want to damage anything, so you do want to take it a little bit carefully. However, an alternative approach I have found is also just to get the screwdriver and use that rather than the tweezers, which is can be a bit slow. There we go. Let's just move that across a little bit. You can see this screw terminal a little bit more clearly. On the T962A oven, the connectors here are the front and rear thermal couples inside the oven. On the smaller oven, the T962 oven, they are the left and right thermocouples. But in this oven, and it is the front and rear ones. So let me just get my screwdriver. I've got one of these little micro screwdrivers. There we go. This is a lot easier, sort of just gouge it out. It's pretty well in there. It's the silicon sealant. It certainly sticks like the proverbial to a blanket. There we go. Just get that into the head of the screw and just back it out. In fact, that's probably the easiest approach. Stick it in the screw, wind it down once you've got into the screw head, and then just back it out. Excuse my hand here in front of the camera. It's pretty tricky trying to do this and film it at the same time. Right, yep, that seems to be easy. And it also, just by unscrewing the screws, seems to release off the silicon. You can see the screw head's quite clearly there. And now, just work out those the terminals for the thermocouples. It's worth noting here, there's a red and a black one. The red one is the positive and the black is the negative. That's pretty standard practice for most things in life, or certainly most things electronic. And on my breakout board, let's bring that in here, the top ones are the positive terminals, and the sort of second one in is the negative. You can't see this very clearly, but just what's going on. So like, if you look at the T1 connector on your breakout board, you'll see there's a positive connections first, then the negative, then the T2 has a positive, then a negative, T3, T4, so on and so forth. Just make sure that the red cable goes into the positive. It's not a big problem if you get it around the wrong way. The only thing that'll happen is you'll end up measuring temperatures in reverse, so it'll go down. Right, I'm just adding my board on there on top of the ISP point. It holds it nicely in place, it makes it easy to work with. This allows me to work out the length where I want to cut the cables to make sure they can reach round to the relevant screw terminals on the upgrade card. This is the fan cable. Excuse me. This is the fan cable that needs to be attached also to the relevant screw terminals. It's switched via the ground cable. The ground cable is the sort of solid red one, and the white cable with a little bit of red writing on it is actually the live. We want to split the live cable as well because we want to take a 12 volt supply off there for powering potentially the internal thermal fan if you wish to make that amendment to your oven. Like I said earlier, I don't think it's necessary, and it's an awful lot of effort for something that has very marginal, if any, benefit. These are the thermocouple connections which I've just been pointing at. They start at T1, T2, T3 and T4. They're quite clearly labelled, and as you look at the screen on the left hand side is the connections for those. The bottom one for T1 is the positive, and the one above it then is the negative for T1, followed by the positive for T2 and the negative for T2, and the positive for T3 and the negative for T3, and the same for T4 as well. The fan is switched using the using a transistor on the board. That's a pretty standard method. If you want to look that up on the internet, feel free. What else is there to say here? Not really sure what else I've got to say about this actually. I don't remember exactly what I was talking about. It's interesting noted in the ISP header actually has a ground connection on it. It has a TX and RX on it, which is how it's programmed, and indeed it has a reset button to allow it to go to allow you to put the controller, the microcontroller on the motherboard into reprogramming mode. Right, here we're just trying to work out the right length of the cable. You know, I'll leave a little bit of excess in case anything goes wrong. Cut it off here, strip it back, so just adjust it slightly to make them slightly longer. Here we go. Ching, right. It's very worth noting at this point as well. See the micro USB connection on the controller upgrade card. That allows you to attach a USB cable. In effect, it becomes a COM port, which allows you to program or reprogram the CPU on the motherboard, and it also allows you to get real-time information during the reflow process. It gives you, I think it's about 3 times a second. It gives you all the temperature readings across the board from all 4 thermocouples if you have all 4 connected. There's no need to have all 4 connected. You can just have T1 and T2 connected, but if you add T3 and indeed T4, it allows you to have 2 further points of measurement within the oven. I tend to attach those to some point on the PCB that I want to monitor. These are these bootlace ferrules. Just pop on the end like that. It basically gives you really nice all the individual wires go inside the connector there, and then you crimp it shut. Makes for a very nice tight connection, absolutely impossible to remove without damaging the cable, and it means you get a nice surface area connection. When you insert it into the screw terminal, rather than just squashing all the cables a bit. Oh, I've bent that a bit. Oh, this is not good. I'm going to have to replace that one. Let me just whip this off. Sorry about this. I tried to get it right first time, but these are all the sort of issues you'll be dealing with as well. Strip it back again quickly. There we go. I've got all things all a bit precariously balanced here. I'm trying not to crush the cables on top of the on top of the oven, and I've got this balanced on top of the oven with the camera just suspended above it. Put the ferrule back, put the bootlace ferrule back on. Add the crimping tool. Squeeze. There we go. Right. Try again. Don't know what happened there. These are normally quite good. Right. Obviously didn't have the wire in properly. There we go. Wire in. Squeeze. Done. And then what we do is just trim off the end. It's a little bit too long just to go into those screw terminals for take off, I don't know, about 1/3 of the length of the protruding connector. That should go in nicely now. So let's get the screwdriver. Make sure it goes into 3.3 volts, which is the third connection. Goes in nicely there, and screw it in. Firmly, not too tight. That's certainly not too tight to damage the ISP connection. That's what's holding it in place. And then here we have the this is the fan connection used to switch the little internal fan on and off, which mainly is kept off now because we have accurate cold junction sensors on these thermocouple chips, so we don't need to keep the oven at some arbitrarily ambient temperature, which we assumed, or which they assume to be 25 degrees Celsius. Obviously that's completely wrong if you live in a hot climate or indeed a very cold climate. And indeed having an oven just below you being heated up obviously affects the ambient temperature and buggers up your temperature readings by quite a large margin. I mean, we're talking about 20 to 50 degrees out. That's enough to either cook your chips something rotten or indeed not melt the solder, depending on which way the discrepancy is. Yeah, just crimp this down. There we go. Cut the end off there. Like so. And we'll just insert that into the ADO connection, which is the second one in. You can just about read these on the upgrade board. They are labelled, but it's quite hard to read them. Anyway, second one in, ADO connection. Perfect. And last but not least is the one wire interface. So once again, we're going to just make sure we've got the right length. Yeah, and then cut it off about there. Where are my pliers? There we go. Chop that off. Yep, that's right. Chomp. Get the wire strippers. Strip that back. Get a bootlace ferrule. Stick that on the end. So, yep. And get the crimping tool. Stick it in the hole. Big squeeze. It's all lined up. And there we go. Once again, just chop off the little bit at the end there. Take off the top third, so it fits in nicely to the screw terminal. Let's bend it round. Come on. Oh, there we go. And screwdriver, and screw that down nice and firmly, but once again, not too tight. There we go. So, well, there are the three main connections sorted out. And the next thing to do is possibly to look at the, let's get that out there. Oh, there we go. Move that out of the way. Right, looks like I'm going through the pins here. This is the ground. Then we've got a TX and RX settings, and that's the reset button, I think, or the ISP one, and the one next to it is the ISP enable button. You don't have to worry too much about those at all. They're just used as doing the reprogramming of the system. We'll talk a bit more about those on the instructions, and I'll take a picture of it as well and reference it a bit more clearly. It's not very clear on this video. So right, next we're going to look at is the fan controller. This needs to have enough length on it. Once again, it's you want to make sure you don't cut it too short on either side, or allow too much length either way. It's about in the midpoint to this connector, not the midpoint of the cable, the midpoint to the connector. Just think about it twice before you cut it, and that way you won't have to rewire the fan or put a new cable in. Right, let me just go and find my nippers. And we'll cut this cable. Here we go. Find the right position. That's pretty good to me. That'll do. So it's worth finding out which is the ground here, because it's going to be switched via the ground. That's what you do with the transistor switching, or you do with its NPN. It's an NPN transistor we're using, and so we're going to be switching the ground wire. Like I said earlier, we also want to take out the live side. The live side is used as a 12-volt supply for the internal thermal fan. If you're going to make that modification, we don't go through all this again, but you obviously don't need to do that modification, and it's quite time-consuming if you do. Plus, you have to dig around with all the insulation on the board, in the oven, find the right size motor. A real pain. You have to make some little custom fan to circulate the air. Right, anyway, so it's quite nice. This cable, at least on mine, and it might be worth testing this, the ground cable for the fan and for the ground coming off the board is actually the one that is got lots of red on it. In effect, it's got the red marker. The live cable has a little bit of red writing on it and is mainly a light grey or white, depending on which way you want to look at it. We can test it quite easily if we get the multimeter out, which is what I've done there. Put on the continuity settings. Touch the one of the probes to ground. Oh, just nudge the bloody board there. Right. Touch one of these to ground, and then touch it to touch the other probe to one of the cables. Right, that's live. That's going to go beep. You just have to imagine it goes beep because the sound's unfortunately missing off this. It goes beep quite nicely then, and that is how we know it is the ground connection. Once again, just quick test back on the live. It doesn't make a noise, and indeed the brown does. So therefore, we can assume that that is the ground connection, and that's what we want to switch. So tidy it up a little bit, and we're going to get one of our bootlace ferrules. We'll put some bootlace ferrules on here. What we're going to do with the live side, we're going to join both lives back together again because we want the live connection running through to the fan, but we're going to put a slightly larger ferrule on there, bootlace ferrule, to allow us to take a tap off the power supply. Right, let's see if this works. It's I'm going to try one of these blue ones are pretty small actually. I can't remember exactly what size they are. No, I can't. But they're pretty small ferrules. But I'm hoping we might be able to join both the cables together with this. So let's just strip this back. There we go. Twist these together nicely. Like so. Try and make sure they're well twisted. You don't want them coming apart. Just insert this in here. This is going to be a bit tight. I'll let them come apart as well. Excuse my hands here in the video. I'll screw these up nice and tight. Is this going to work? Let's just see if we get this to fit over both of them. No. No, that's not going to look nice. I don't think we'll take that off there. And we'll go and get a slightly larger ferrule. I've got a red one, which I think is the next size up, which I think will be just about wide enough to go over the, well, the little plastic bit at the end will go over the wire ends. Here we go. Ah, that's looking a lot better. Here we go. Get the crimping tool out. Stick it in the hole. There you go. Big squeeze. Come on. There we go. So that's the two live wires joined back together again. So it's got continuity back to the fan. But we've also got now a little junction point which we can take off a tap for the 12 volt supply. Right. Do that in place there. So next thing we need to do is put some bootlace ferrules on the two grounds here. One that goes back to the fan is obviously going to be the switched one, and then we've just got the standard ground connection, for want of a better word, on the other side. The wire that goes off to the right hand of the screen is actually going off to the fan, and indeed the left side of it is going back onto the motherboard, or the mother controller card. Put this ferrule on here, get the crimping tool, give that a quick crimp, like so. Cut the end off. Crimp this one as well. And this is the ground. There you go. And we'll just trim the end off once again. Hope this is not too boring for you. This is real time. This is how long it actually takes to do all the work, and it'll give you a pretty good indication of what you're going to be embarking upon yourself. So, right. So, which one are we going to stick in first? Let's go for the ground here. This is like the third one in from the bottom of the screen here. And then I'm going to go for the 12 volt supply that goes in next to it. Identified as 12V, quite not cleverly, but quite clearly on the board there. It's a bit tight fit, this one, because as you can see, the ferrule is slightly larger than the others. There we go. And last but not least, let's slip in the ground from returning from the fan. And this goes into the actual fan connection, and is actually used to switch the fan on and off. There we go. Just use a screwdriver there just to slide. There we go. Nice and flush there, and we screw that one in. So the only other two connections at the bottom here are for if you ever do install an internal thermal circulation fan. I don't plan to do that on this demonstration, but that's all you need to do is add the motor, connect it by those two connections which are left on that side, and it will in effect power the fan for when you turn the oven on. Right, so next we're going to look at is the thermal, the thermocouples. Once again, it's just another little reminder here that the red one is the positive and the black is negative. You'll see as we take these existing bootlace ferrules off, the cable itself is actually wrapped in some sort of red braid, so it's pretty obvious. So we cut these off here, being careful not to to pull the, you see the sort of that big piece of loose braid, or on the which actually goes around two of the wires. Let me just bring this across. Give me a second. Right. Oh, this is right. Obviously, that's where they need to be connected to, over here. And the first one, as I already said, is the positive one. The positive one is the red one. There we go. Let's bring this into view a bit more. There we go. Right. Red cable, positive. White one now is the negative, and the red one needs to go into the first screw, and then the second screw connection is for the negative for T1, then the third screw will be the positive for T2. Stripping these off is a bit trickier. I don't know what they've used to actually encase the wires, but it's like some sort of high temperature fiberglassy type insulation. I guess it's, you know, obviously designed to withstand, I think, up to 700 degrees, maybe more. I'm not sure. So it does seem to cut sort of okay with the Stanley knife here. Well, not Stanley knife, actually it's craft knife. But probably not the best platform. I would probably do this on a piece of wood, but I'm trying to show you what I'm doing. So I'm going to use the my PCB upgrade card as a little tabletop there, and just prising the wire out. It's just a single solid core wire in here. The way the thermocouples work, they are two separate two wires made of two different materials, and when they heat up, there is a change in the charge difference between the two different types of wire, the two different materials. It's a very small difference, but that's what's actually used to make the measurements. The original controller card used the analog to digital converter on the LPC chip to make this measurement. It's only 12-bit resolution, and it really isn't good enough. I think I'm fairly safe in saying the chips on my upgrade card are 16-bit, and they have the cold junction compensation in there as well. Far more accurate. I mean, plus or minus 2 or 3 degrees through the temperature range used on the reflow oven. I think the temperature range goes out to plus or minus 5 degrees when you're getting up to 1,000 degrees Celsius. But if you ever get your PCB oven up to 1,000 degrees Celsius, something's gone horribly wrong. So we're adding this bootlace ferrule onto here. Go and find the crimp tool. Stick it in here like so. Oh, right. This is all a bit precariously balanced, I'm afraid. Let's try again. Sorry, my hands are right in the way of the camera here. I'm sure you've seen this enough times now. Insert the wire into the ferrule, insert the ferrule into the crimp tool, squeeze the crimp tool. Hey presto. Alright, so we need to expose the negative. We're going to try and use the wire cutters here. They're not really what they're designed for. It won't work very well, but it might just make it a bit quicker and a bit easier than using the Stanley knife, or the scalpel, should I say. I'll just try and peel this out of here. I tried to remove all the insulation around it to make it stand out. It's quite tricky to do because I said it's like fiberglass. It's very strong fibres I've used here, and they kind of just stick together and keep bouncing back. If you can really get it exposed properly, you can get the nippers in and then just cut off the excess insulation before there we go. Pop that in there. Yeah, well, that's going to work, but probably just need to get rid of some of that excess insulation. There we go. tricky, this bit. Just trim this down once, twice. And there we go. That's looking good. Get the bootlace ferrule. And insert it like so. Oh, come on. There we go. Looking nice enough. Crimps all out. Big squeeze. There we go. And just need to trim the ends off now, and we'll insert those into the relevant positions. So I will say this for one last time. Note the red one must go in the positive. Well, like I say, it's not terribly important. It'll just read around the wrong way, and it'll just go down in temperature instead of up when you turn the oven on. However, save yourself the effort of doing it twice. Just trim the ends off these, and you'll see that we'll screwdriver. Right. It's a bit tight here. I'll tell you what we'll do. We'll cut the cable tie off here. There we go. Allows a bit more room for moving around. Come on. It's lined up. It's very fiddly with the camera about, 2 or 3 centimeters above your hand as well. Right, come on. Just back the screw off a little bit. There we go. Right, that's nicely in. Screw it down. Put it back a bit. Expose the cable. And here we go. Slip that in like so. And you need to do the same for the second thermocouple. And indeed, if you want to put the other 2 thermocouples on, you need to do a very similar thing with the thermocouples you've got. I don't really propose to show you any more of. I don't propose to show you putting the other thermocouple on. You probably had enough of that by now. So I shall leave you to your own devices on that. I'll put a picture at the end of what that should look like. Thank you very much.